So let's take a look at number 3 here. The first thing I want you to do in number 3 is just kind of take stock of all the things you see in the picture. There are multiple ways to view this picture. The first thing that I see is that these two outside triangles form that butterfly picture like we saw in the first example. So I have vertical angles, I maybe could do some other things. So I see that. I also see this set of overlapping triangles which have that reflexive side of AB. So perhaps those are the triangles I would be using. I also see that they overlap at the bottom this way. And so I have a reflexive shared side of CD. Perhaps I'm going to only be looking at this little triangle, or perhaps I'll look at this bottom triangle. They're probably not congruent, but maybe there's something through CPCTC that I could say about those. So I have multiple ways to see this picture, and that just emphasizes how geometry is all about a pattern, not a formula. I could give you the same picture with a different given, and we would have an entirely different proof. So the first thing we have to do is say, well, what are we trying to prove in this scenario? I'm trying to prove that angles 3 and 4 are equal. So 3 and 4 are up here in this little triangle, and I'm just going to mark them in yellow. So they could be part of those overlapping, sharing AB. They could be a picture in and of themselves. So we just kind of have to wait and see where our given now starts us. So when we look at the given and we make that T-chart, and we write our given down, angle 1 is equal to angle 2, and AC is equal to BD. Given 1 and 2, AC and BD. Now, those two pieces of information are kind of dead ends because they don't give me anything else. But what they do give me is a direction as to which triangles I'm looking at. So if I look at this side, which is given, and this angle, that lends me to see that, well, they would, with that side, make a triangle in the same way. So I kind of trace my given, and now I realize I am looking at the two butterflies. Well, in that butterfly picture, I know that I always have vertical angles. And so I'm going to prove that angle AEC, I'll try to write that neater for you. Angle AEC is equal to angle BEC by reflexive. I all of a sudden have my two blue triangles congruent by angle, angle, side. Now how does that help me? Well, if I write that down, triangle CAE is equal to triangle DBE. Again, order matters. And remember, that's by angle, angle, side. What I can see happening is now I know something about AE and EB. In the fact that I know that AE equals BE by CPCTC. Those are corresponding parts of congruent triangles. And you may have to turn your paper upside down, but when I do that, I see now in looking at that top little triangle that AE and BE are two equal sides of a triangle, which means it's isosceles, which means that angle 3 is equal to angle 4 by the isosceles triangle theorem. Those angles being equal tell me the base angles are also equal. So that is how that proof will work its way around from congruent triangles to CP/CTC to the isosceles triangle theorem to my base angles being equal.